This time we are going to make a focus on quadrilaterals. As you may remember, last class we saw the classification of triangles. Now we will do the same but for quadrilaterals. Quadrilaterals are figures that have four sides, okay? Any figure that has four sides, it's named as quadrilateral. But quadrilaterals can be subdivided into different kinds. Just like we had three different types of triangles, we have several types of quadrilaterals, okay? These here, all of these, as you can count, all of them have four sides. All of them are quadrilaterals. But we can go being more specific and more specific and more specific about them, okay? So we will start by naming the trapezoid. Trapezoid is the second biggest figure we see here. And their characteristic is that they have at least one pair of parallel sides, okay? Remember, parallel lines are lines that will never touch because they go in the exact same direction, okay? So, trapezoid has one pair at least of parallel lines. And here we can see them. These are the two parallel lines. The other two sides are not parallel. If we continued these segments, they will touch, okay? Now, all of the other ones that are inside, they also have at least one pair of parallel lines, but they have another characteristic, okay? So the next is the parallelogram. Parallelograms, they have two pairs of parallel sides, okay? And here we have an example, okay? These two sides are parallel and these two sides are parallel as well, okay? Now you may notice that the figures inside also have two pairs of parallel sides, but they also have another characteristic, okay? That is why they are inside, because they are included in the general, but they also have a specific characteristic, okay? Each time we go further and further inside, we will have more characteristics, but they will continue to comply with the general characteristic that is outside of them. Next, we have the rectangle. The rectangle, apart from having two pairs of parallel sides, it has four right angles, okay? Parallel sides, but also right angles, okay? Now, you see that this figure here is not included inside the rectangle. Why? Because it doesn't have right angles, okay? So it's not inside of this characteristic, but it is inside the characteristics of the parallelograms, okay? This is called a rhombus. The specific characteristic for rhombus is that it has four equal sides, okay? They have the same measure. Now, inside both rectangle and rhombus, we have the square. Out of all of these, the square and the rhombus are the only regular polygons, okay? Because they have equal sides and equal angles. Now, square is inside of both. Why? Because it has the characteristics of both. It has the characteristics of the parallelogram because it has two pairs of parallel sides. Also, it has the characteristic of the rectangle because it has four right angles, and it also has the characteristic of the rhombus because it has four equal sides. Okay, So those are the subdivisions of quadrilaterals. Remember, the ones that are inside also have the general characteristics from the ones outside. Okay, so is a square also a parallelogram? Yes, because it has two pairs of parallel sides. Is a square also a trapezoid? Yes, because it has at least one pair of parallel sides. Is a square also a quadrilateral? Yes, because it has four sides, okay? But if we are asked, we are going to say the most specific one that we can, okay? Next, we will talk about diagonals. What are diagonals? Diagonals are a segment that goes from one of the vertex to another that is not adjacent to it. Remember, adjacent is that they are next to each other, okay? Adjacent vertex are already joined by a segment, okay? That is a side. So we are going to trace diagonals only on vertices that are not already joined by a side. In quadrilaterals, we only have one diagonal, okay? Let's see some examples for other. Now, diagonals can work for us to divide figures into triangles. And we already know that the inside angles of a triangle all add up to 180. Why do we need these for? Because if we divide the figure in triangles, we can know what the sum of their internal angles are going to measure. Okay? How do we do this? We trace all the diagonals that we can, starting from just one vertex. Triangles don't have vertices that are not already joined, so triangles have 0 diagonals. You already have a table like this in your presentation, okay? So, how many diagonals do triangles have? 0. How many diagonals do quadrilaterals have? If we take this vertex as our point of reference, it is already joined with this one, and it is already joined with this one. So we will only have 1. How many triangles are formed in here? We have 2 triangles. We have 1 diagonal, 2 triangles. Now, if each of these triangles, its angles measure 180 in total, what would be the sum of all of the angles of the quadrilateral? It would be 360 degrees. Let's do the same for the pentagon. Let's take this vertex as our reference. It is already joined with this vertex. We are going to join it with this one and this other. Okay, now we have 2 diagonals forming 3 triangles, and each triangle has a total angle measure of 180. 180, 180, 180. What would be the total measure of the internal angles of the pentagon? It would be 540 degrees. Okay, and we could use this to measure the internal angles of any polygon. okay? We could get a formula out of this, okay? We have, how many sides do we have in the triangle? We have 3 sides. In the quadrilateral we have 4 sides, and in the pentagon we have 4 sides. Now, this quantity of sides, we are going to represent it as an n. N equals the quantity of sides. Now, we have 3 sides on the triangle, 0 diagonals. 4 sides on the quadrilateral, 1 diagonal. 5 sides on the pentagon, 2 diagonals. What is the pattern we are following here? The number of diagonals equals the number of sides minus 3. This is the number of diagonals every time. So if we have a polygon that has 24 sides, it will have 21 diagonals, okay? 24 sides and minus 3 equals 21 diagonals. Now let's do the same to find the number of triangles. Triangles have 3 sides and it's just 1 triangle. Quadrilaterals, 4 sides, 2 triangles. Pentagon, 5 sides, 3 triangles. That means that we are going to take the number of sides minus 2. That is the number of triangles that will be formed with the diagonals. Okay, so if we have a polygon that has 100 sides and we made the diagonals from it, we will get 98 triangles. Okay, and lastly, how do we get the quantity of the sum of the internal angles of the figure? Okay, well, we will multiply the number of triangles by 180. We already know how to get the number of triangles, so our formula would be the number of triangles, which is n minus 2, multiplied by 180. Using this formula, we can get the sum of the internal angles of any polygon, okay? As long as it is a convex polygon. And now, you can do this for the exercises that are on skill check number 2. And that's it for the class. If you have any questions, please log into the Facebook Live Q&A. I hope you have a very nice day. Bye-bye.